Alright guys, so in this lecture 5.3, sum and difference identities for cosine. The cosine of sum or difference of angles can be written as a sum of products of the sine and cosine of each angle separately. So you should be able to work with the sum and difference identities to find exact values of additional angles and simplify expression involving the cosine of the sum or difference of angles. You have to remember, and you will have this formula on your flashcard for the final, at least. I'm not sure really for the exam corresponding to that section, but I will ask you to fill up the blank that you have on your paper right now, on your lecture note that you printed out. And try to not copy for just the sake of copying, but try to copy, trying to understand what happened in order for me to prove that cosinus A minus B equal cosinus A, cosinus B plus sinus A, sinus B. That will help you to manipulate the cosine and sine of a sum or differences in this section 5.3 or 5.4. Ultimately, it's a good exercise. So, cofunction identities, cosinus of 90 degrees minus A equals sinus A, you will have to use that also. I just would like to write a note for you that these cofunction identities are true, and I'm going to write with another, I'm going to write in black for once. They are true for any angle A and not just acute angle. Okay, any angle. All right, so let's try to work on the first problem, find the exact value of cosinus negative 75 degree. Well, first of all, cosinus of negative 75 degree, it is equal to what? That's the first thing you may want to look at, and it's equal to cosinus of 285 degree. So finding the cosinus of negative 75 degree, it's finding the cosinus of 285 degree. You should have your trigonometric circle with you, and you should look for angle that could help you to work with 285 degree. And obviously, 285 degree is 225 plus 60 degree. If you apply the formula, you end up to have cosinus of 225 plus multiply by the cosinus of 60 minus sinus 225 sinus 60. Looking at your trigonometric circle, you end up to know that you have negative square root of 2 for 225 degree for the cosinus, multiplied by 1 over 2 for the cosinus of 160 minus same idea, negative square root of 2 divided by 2, and because I'm dealing with a negative number, I'm using my parentheses. I could have used a parenthesis right here, but it's not such very important because there is nothing in front. On the other hand, with the subtraction sign right here, negative by negative, if I may speak like this, that will be transformed into a positive number. So I must pay attention to that. So therefore, I end up to have a value equal to negative square root of 2 divided by 4, negative square root of 2 divided by 4, plus square root of 6 divided by 4, and therefore the answer is going to be square root of 6 minus square root of 2 divided by 4, which is around 0.2588. Now, let's work this out for the second. Well, for the second part, what I want to do is transform 17 pi over 12 into cosinus 15 pi over 12 plus 2 pi over 12. All right? Why 2 pi over 12? Am I looking for a 2 pi over 12? It is because 2 pi over 12, it's pi over 6, and I know the cosinus of 2 pi over 6. Okay? So I end up to have, at the end of the day, cosinus of 15 pi over 12 multiplied by the cosinus of 2 pi over 12 minus the sinus of 15 pi over 12 times the sinus of multiply, every time it's multiply in between, pi over 6, which is 2 pi over 12. Okay, I'm going to write 2 pi over 12, but remember, that's 2 pi, that's pi over 6. So when I look at 15 pi over 12, 15 pi over 12, 15 pi over 12 can be simplified into a 3 pi over 4, and I know the value of the sinus and cosinus. So I know basically that is going to be cosinus of 3 pi over 4 cosinus of pi over 6 minus sinus 3 pi over 4 sinus pi over 6. Basically, I try to transform the 17 pi over 12 into the sum of two angles that I can use on my trigonometric circle. Therefore, I end up to have negative square root of 2 divided by 2 multiplied by square root of 3 divided by 2 minus negative square root of 2 divided by 2. I'm using my parentheses right here, multiplied by 1 over 2, and I end up to have, at the end of the day, a negative square root of 6 minus square root of 2. Please do the calculation and you will check that numbers by yourself. On this example number 3, the only thing that you need to do is realize you have cosinus A, cosinus B plus sinus A, sinus B, and you know that is equal to cos of 173 minus 83. You take your calculator, you realize it's equal, well, you don't even need to have a calculator because this is cosinus of 90 degree, and cosinus of 90 degree, it is 0. All right, so let's work the B now. Okay, so what do we have? We have write each function value in terms of the cofunction of a complementary angle. So from what I know, tangent of an angle A equal cotangent of 90 minus A. Therefore, tangent of 87 equal cotangent of 90 minus 87, which is cotangent of 3. I'll let you do the calculation. Now let's look at sinus of 5 pi. Well, in that case, I know that sinus of the angle A equal cosinus of 90 minus the angle A. Therefore, if I transform 90 into pi over 2, which would be cosinus of pi over 2 minus A, with A in radian, which is the case here, sinus of 5 pi over 8 equal cosinus of pi over 2 minus 5 pi over 8. And I need to multiply by 4 top and bottom to have the same denominator looking like the LCD. I would like to remind you that in that case the LCD is 8, which means 2 cubed. So I end up to have sinus of 5 pi over 8, I can use some parentheses right here, equal cosinus of 4 pi over 8 minus 5 pi over 8, which is cosinus of negative pi over 8. Now, with the same idea, find an angle theta that satisfies each of the following. So you have sec theta equal cosec of 62 degree. Well, you know that you can write sec theta equal sec of 90 minus 62 degree. Why? Because cosec of 62 equals sec of 90 minus 62. Just take a look back to the formula you're supposed to know. the cosec of A equals sec of 90 minus A, and the cosec of 90 minus A equals sec of A. So I transform my sec of 90 minus A into the cosec of 62 into the sec of 90 minus 62. Therefore, I can easily compare theta with 90 minus 62, and I can easily say now that theta equals 90 minus 62, which is 28 degrees. I'll let you do the problem B as well as C. They are very simple, similar. You should be able to do that very easily. And let's try to work on the number 3. The following problem or example of reduction formula, and write cosinus 90 plus theta as a trigonometric function of theta alone. So let me work this out with you a little bit. So what do we have? We have in cosinus of the angle 90 minus 90 plus theta. So 90 plus theta. And it is equal to what? Well, based on the formula, you are supposed to write cosinus of 90, cosinus of theta minus sinus of 90, sinus of theta. You know that cosinus of 90 equal to 0, so you got 0 multiplied by cosinus of the angle minus sinus 90. You know that sinus 90 is equal to 1 multiplied by sinus theta. Therefore, you end up to have this is equal to sinus theta. So I'm asking you to do the same thing with B, C, and let's work together D. Write sinus 270 degrees, there we go, minus theta as a trigonometric function of theta alone. Well, you need to realize what is the pattern that we work on, okay? And let's try to see what can we do. Well, first of all, I can easily say that sinus of 270 degrees minus theta is going to be equal to negative cosinus of the angle theta. If you decide to have an angle theta in a quadrant 1, let's say that you have the angle theta in a quadrant 1, well, add or subtract from the quadrant 1 angle and see what the answer is. And you will see that the answer is negative cos theta. So again, the only thing I need to do is add or subtract it from the quadrant 1 angle and see what's the answer. All right, so let's try to work on the problem E. So on the problem E, tangent 270 degrees minus theta, it's equal to what? Well, it's equal to sinus of 270 minus theta divided by the cosinus of 270 minus theta, which is minus cosinus theta. I just said that previously, divided by minus sinus theta. You will find out very easily, and you are supposed to be equal to negative cotangent of the angle theta. Now, in this last example, suppose that you have cosinus S and sinus T, and S and T are both in quadrant 4. Find cosinus S minus T. So first of all, you need to realize that sinus square S plus cosinus square S equal 1. Therefore, sinus square S equal 1 minus cosinus square S, and so sinus S equal the square plus or minus the square root of 1 minus cos square S. So guys, once you have found sinus S equal negative 8 over 17, to find the expression of cosinus T, why do you need to have cosinus T? And by the way, right here I made a mistake, there is no square, but to find the expression of cosinus T, you need to use the sinus square T plus cosinus square T equal 1. You are going to take the plus on when you're writing the square root, and which means I don't need to have the square right here. You are going to take plus because the cosinus needs to be positive in quadrant 4, and then you will have the sinus and the cosinus you need in order to fill up your formula and calculate the value